Hey everyone, welcome to Fabric Quality Control Full Analysis. I'm your host, QA Jamae. Today we're diving deep into a topic closely related to our work, textile printing equipment and development challenges. Printed fabrics are everywhere in our apparel, but do you actually know how these patterns get there? Today we're inviting QA Ned to unveil the mysteries of print production. Ned, welcome.
Thanks, Jamae. Hello, everyone. I'm excited to share some of these printing secrets with you today.
Ned, you immediately mentioned secrets. Sounds like we'll be learning a lot today. First, I want to ask you a very basic question. What's the difference between printing and dyeing? We often see an entire garment in a single color. That's dyeing. But what about printing?
Oh, these two are miles apart. Simply put, dyeing is about making the entire fabric a uniform single color, like soaking the fabric in dye to let the color penetrate evenly. But printing is completely different. It's about applying color to specific areas of the fabric to create patterns with clear boundaries. It's like using a stamp to apply ink. The resulting pattern has a distinct shape rather than covering the whole paper. This fundamental difference also dictates significant variations in their equipment, dye material engineering, and subsequent processing.
Wow, that's a very clear and vivid analogy. So are the materials used for printing and their application particularly precise? And are there any underlying production principles? I've heard that one of the biggest challenges in printing technology is controlling fluids.
Absolutely. That's one of the key aspects of printing technology. Dyes themselves are water-soluble, but the colors used for printing, which we call print paste or ink, must always have a thickener added to them. Why? Because if the print paste is too thin, the color will bleed when applied, and the pattern will get blurry. Imagine painting on fabric with very watery watercolors. It spreads easily, right? The thickener acts like a concentrated watercolor, making it viscous enough to stay neatly within the boundaries of our intended pattern. This ensures the lines come out crisp and the edges sharp. Getting the consistency of this thickener just right directly impacts the print quality.
I see. So fabric mills also need to record and control the consistency of print paste or inks as part of their internal quality checks. Given that, printing technology must have a long history, right?
Oh, absolutely. The evolution of textile printing technology is practically an epic journey through time. As early as the 12th century, printing technology involved what was called block printing. But back then, due to the material engineering limitations, the pigments were very unstable. They would fade away after just one wash. Plus, block printing was a painstaking process of pressing block by block, which was very inefficient.
Ugh, imagine your clothes fading after just one wash. That would be incredibly frustrating.
Exactly. The true industrialization of printing came in the early 19th century with the advent of roller printing. Following that, manual screen printing emerged, which significantly boosted printing efficiency. With the introduction of machinery, continuous production became possible. But for a truly disruptive change, that definitely came with the iteration of digital textile printing in the late 20th century, specifically the late 1990s. It was seen as the up-and-coming contender in printing. And now, the technology for direct-to-fabric printing has become increasingly mature, completely breaking the limitations of traditional plate making and ushering in a new era of plateless printing. It's like going from carving stamps to direct printing with an inkjet printer. A huge difference, wouldn't you say?
A massive difference indeed. Plateless printing sounds incredibly convenient. So today we'll be discussing two main topics. Besides introducing printing equipment, we'll also touch upon the challenges faced by merchandising and development teams due to this generational shift and improvements in plate making methods. Now, speaking of printing materials, do different fabric types require different inks or print paste formulations?
That's a very important point, and the answer is yes, absolutely. This delves into textile chemistry. Different fibers have different chemical properties, and the dyes that can bond with them also vary. For example, what we most commonly hear about, polyester fiber, is best suited for dispersed dyes, especially for heat sublimation printing. So we must formulate dispersed dyes into a print paste, print it onto paper, and then the dye will gasify and penetrate the fibers during high-temperature transfer. Then there are fibers like cotton and rayon, which are better suited for reactive print pastes, because reactive dyes can form chemical bonds with the fibers, resulting in more vibrant colors and excellent color fastness. If it's silk, wool, protein fibers, or nylon, you'd choose print pastes made from acid dyes. Finally, there's pigment. It's like sticking the color directly to the fabric. It's applicable to almost all fabrics, but it might result in a hand feel on the fabric, making it feel like the color hasn't permeated the fibers. So choosing the correct dye, corresponding print paste, ink, and technique is crucial to achieving the desired color and effect.
Wow, hearing you explain it like that makes choosing the fabric and confirming the production method quite a science. So can all fabrics be arbitrarily combined with any printing technology?
Certainly not. This is a crucial point we must consider when developing fabrics and garments. Let me give you an example. For heat sublimation, also known as paper printing, it's almost exclusively the domain of polyester fiber. If you try to sublimate print on a cotton fabric, the cotton portion will fade significantly after just one wash, because the dye simply cannot bond with the cotton. So for things like sportswear and jerseys, where vibrant colors and durability are key, heat sublimation is particularly suitable. I want to specifically remind you here, besides fiber type, the fabric's surface texture, yarn twist, and weave structure can all affect the print performance. Under the same printing method and conditions, different fabrics will exhibit different results. So fabric selection isn't just an aesthetic consideration, it's a technical limiting factor. Therefore, it's essential to thoroughly evaluate materials and production methods in the initial print development stage.
What you're saying reminds me of a case. Paper printing is often used to make camouflage hunting gear. Yes, the one that helps hunters blend into the forest. Let's look at a real example here. The image on the left is printed on plain weave poplin, and the other is a plain weave ripstop fabric with a square ripstop pattern. We can see the difference in effect when both are produced using the same heat sublimation method.
Yes, I prefer the vibrant feel of the left one. Animals probably wouldn't see you as easily hiding behind a tree. But if the customer insists on the fabric structure and yarn count of the right one, then we must consider the loss of vibrancy, making the whole print look dull. So, besides choosing the correct technique, the base fabric itself is also a key point to note in development.
Ned, you briefly touched upon flatbed printing earlier. Could we now discuss its principles, equipment, and operating procedures in more detail? What makes it unique?
No problem. Despite their long history, they still play a pivotal role in current large-scale textile production. First, let's talk about flatbed printing, and then we'll move on to rotary screen printing. Both are referred to as screen printing because their plate-making principles are similar.
The principle of flatbed printing seems a bit like manual rubbings, but the plate-making process shouldn't be that simple, right?
That's right, Jamae. During the plate-making process, this method utilizes a photolithography process. Simply put, a photosensitive emulsion is coated onto a treated screen. Then, it's exposed using a designed pattern mask, or photomask, and lenses. This step causes the coating to undergo a chemical change when exposed to ultraviolet light. Finally, after washing, only the parts that weren't blocked by the photomask remain.
That sounds fascinating, this photolithography method. What happens next?
Next is to test the correctness of the screen. The operator lays the fabric flat on a printing table, and then this prepared flat screen is precisely placed over the fabric. Then we use a rubber squeegee. The operator places the prepared pigment print paste at one end of the screen and then applies a certain pressure to evenly spread the print paste from one end to the other. As it's moved, the print paste passes through the transparent holes in the screen, precisely transferring the design onto the fabric below, forming the pattern we want.
So if a design has 5 colors, you have to squeegee 5 times?
Absolutely correct. That's the most notable characteristic of flatbed printing. Each color requires a separate screen to be made. Assuming your design has 5 colors, you'll need to produce 5 individual screens and print them in succession to layer the complete colored pattern. Typically, flatbed printing machines can handle up to 8-12 color stations, which also means there's a limit to the number of colors it can print.
Do modern machines look very complex? I assume they're all automated now, right?
Of course, modern flatbed screen printing machines are highly automated, no longer relying solely on manual labor as in the past. Their main components include an in-feed device, which is responsible for feeding the fabric into the printing area, a color paste bucket for storing and supplying the print paste, and most importantly, a rotating continuous rubber blanket where the fabric is adhered to ensure stable movement during printing. Of course, there's also the flatbed printing frame for precise raising and lowering of the screen and an automated squeegee system for uniformly applying the print paste.
The whole process sounds quite automated. So once it's printed, is that the finished printed fabric?
No, the printed fabric is not the final product. It needs to go through a drying process with a drying machine to cure the colors. This is a high-temperature process that ensures the dyes or pigments are firmly attached to the fibers. Afterward, it will undergo a washing process to remove any excess unfixed dye or residual strong chemical auxiliaries. These 2 production steps are commonly referred to as steaming and washing, which is why some people also call reactive printing steaming and washing printing. Finally, it goes through a setting process to restore the fabric's stability and achieve the desired dimensions and hand feel.
I see. So what are the advantages and disadvantages of flatbed printing?
The advantage of flatbed printing is that for large volume production, the cost per yard is very low. And because it's a mature technology, it's easy to achieve high color saturation and a soft hand feel in the printed result. However, it also has some distinct disadvantages. Similar to rotary screen printing, which we'll discuss next, the biggest one is the need for plate making. Each color requires a separate plate. For orders that don't meet the printing factory's MOQ, they might charge plate making and machine setup fees. Additionally, due to multicolor overlaying, especially for full coverage prints, the back of the print might show seam lines due to uneven penetration. Furthermore, flatbed printing is not suitable for straight stripe patterns, and the screen also has pattern length limitations.
Thanks, Ned. Let's give our listeners and ourselves a short break to digest all this information. We'll be right back to delve deeper into another traditional printing giant, rotary screen printing. How does that sound?
Great idea. To all our listeners, grab a drink, stretch your legs, and we'll be right back to unveil the mysteries of rotary screen printing.